Your computer has a magic book, and it's constantly tearing out the pages you might need tomorrow. Here's the lie you're told. Your computer has 16 gigabytes of memory. The truth? It has access to terabytes, a near-infinite virtual address space on your hard drive. The problem? That infinite library is agonizingly slow. The tiny RAM bookshelf is fast, but can only hold a handful of pages at a time. So the operating system performs a magic trick. It makes you feel like the entire infinite library is in the fast shelf. It's called virtual memory, or the impossible prediction. The system breaks everything into fixed-size pages. Your code, your data, your cat video, all just pages. Most of them live in the slow infinite library, the disk. Only the pages you're actively using get a precious spot on the fast shelf, RAM. And it works until the shelf is full. You click something new. It needs a page. That page isn't on the fast shelf. This is a page fault, a system interrupt, a crisis. To bring the new page in, you must evict an old one. You must choose a page to tear off the shelf and send back to the slow library. Which one do you choose? This is the paging problem. It's not about memory, it's about time travel. You must predict the future. You must guess which of these pages will be needed the farthest in the future, because that's the one you can safely remove. The ideal algorithm is called OPT, Optimal Page Replacement. It has a crystal ball. It looks into the future, sees the exact sequence of all future page requests, and always evicts the page that won't be needed for the longest time. It is mathematically perfect, and it is impossible. Your computer cannot see the future. So, engineers build profits from the past, guesses, heuristics. 1. FIFO, first in, first out. The dumbest guess. Treats memory like a line at a coffee shop. The page that's been in RAM the longest gets evicted. Simple, brutal, often wrong. 2. LRU, least recently used. A powerful guess. It assumes the past predicts the future. The page you haven't touched in the longest time is probably the one you won't need soon. It's eerily good. 3. The clock algorithm. A clever, efficient approximation of LRU. A clock hand sweeps through pages. If a page was recently used, bit equals 1, it gets a pass, and its bit is cleared. If it's unused, bit equals 0, it's evicted. A game of hot potato. And here's the mind bend, the Belady's anomaly. With the FIFO algorithm, giving the system more physical memory can sometimes cause more page faults. Performance gets worse. It's proof that in complex systems, even obvious solutions, more RAM equals better, can backfire spectacularly when your prediction model is flawed. So every nanosecond, your OS is doing this. It's using a flawed profit, LRU clock, to guess what you'll do next based on what you just did. It gets it right maybe 99.9% of the time. That 0.1% is the stutter, the microlog, the why is it freezing? The takeaway is not that computers are psychic. It's that they create the illusion of infinite instant memory by constantly making a brutal predictive bet. A bet on your behavior with a CPU cycle as the wager and system performance as the pot. Your computer doesn't know the future. It just pretends to, so well that you almost never notice it's guessing until it guesses wrong. And for a split second, the magic book shows its torn edges. The paging problem, the art of forgetting the right thing at the right time to give you the illusion you forgot nothing at all.